Today's forecast calls for a high of 900 degrees, a steady rain of sulfuric acid, and an atmospheric pressure high enough to crush your bones. It sounds like hell on Earth, but it's just another day on the planet Venus. Scientists warn that the weather on Venus is a sneak preview of the future on Earth.
Eventually, the Earth will experience a runaway greenhouse. It is just a matter of time.
What would happen if Earth had to face this fate tomorrow?
We would be in deep trouble. We would be fried to a crisp and crushed beyond belief.
To a very different Earth. Our weather has been replaced by some of the hellish weather from Venus. It's not a pretty picture. In fact, as far as life is concerned, it's the end of the world. Our lakes and oceans boil and evaporate. Our cities collapse into blazing infernos. Our monuments dissolve in a torrent of sulfuric acid.
If the weather on Venus were to suddenly descend onto the planet Earth, it would, well, it would be a bad day.
Venus-like weather on Earth may seem unthinkable, but in fact, most scientists believe that it's inevitable. So they're struggling to understand how things on Venus went so disastrously wrong.
It's kind of a sobering, advanced look at what the weather over the really long term is going to be on Earth.
To understand how the weather on Earth could spiral into what scientists call a runaway greenhouse effect, we need to understand how a runaway greenhouse already happened to Venus, a planet that started out a lot like Earth.
Venus is the second planet from the Sun, and it's sometimes called Earth's twin because it's so much like Earth. It's almost exactly the same size, and it has a big, cloudy atmosphere. Looking at it from space, you might think it was just like Earth.
But when it comes to weather, the two planets are literally worlds apart.
The major differences between Venus and Earth are that Venus has a much, much thicker atmosphere.
Temperatures are 900 degrees Fahrenheit, hotter than a baker's oven, hotter than the melting point of tin and lead.
You might assume Venus is so hot simply because it's closer to the Sun. But in fact, if you took Earth and moved it as close to the Sun as Venus, global temperatures would merely rise by 20 to 30 degrees Fahrenheit.
It would not be so hot that life wouldn't have a problem.
What really makes the weather on Venus so much hotter than Earth is the thickness of its atmosphere. On Earth, the air is a light gas. On Venus, it's a thick, broiling soup.
By far the most significant fact about the weather on Venus is that the atmosphere is roughly 100 times denser than on Earth. And so that dictates every feature of the Venusian weather.
The atmosphere is so thick that walking through it would be like walking through water.
Trying to move against it would be incredibly difficult. You really couldn't move easily through the atmosphere of Venus.
Although surface winds are calm on Venus, even a light breeze could cause problems.
The winds on the surface of Venus are quite slow. They're moving at just a few miles per hour. But because there's 95 times as much atmosphere at the surface of Venus, the wind at a given wind speed has 95 times the amount of ability to kind of pull you along. The whole atmosphere is moving kind of like a river.
A 5 to 10 mile an hour wind would probably knock you over.
As a tourist on Venus, you might feel a lot of pressure to see the sights, but you'd also be under a different kind of pressure, the kind you wouldn't survive.
The pressures on the surface of Venus are about the same as going a half-mile down in the ocean. Divers can't go that deep. It's just lethal. It would crush them, and it's the same on the surface of Venus.
Take a car, which weighs 1,500 pounds, and put it on every square inch of your skin. Within seconds, you'd be crushed like an eggshell.
But on Venus, the pressure might not have a chance to kill you because the heat would cook you first. On Earth, the highest temperature ever recorded was on July 10th, 1913 in Death Valley, when the mercury hit 134 degrees. But that would be far colder than the coldest day on Venus.
The temperature on Venus is roughly 800, 900 degrees Fahrenheit. That's hotter than the oven cleaning temperature setting on your oven.
Humans have been exploring Mars for years with remarkable success. But the searing heat of Venus makes exploration practically impossible.
On Mars, we can land a rover down and drive around for 6 years. On Venus, we landed that same rover down, it would start to melt into a pile. Imagine the solder on the electronics just turning into liquid and flowing out.
And unlike Earth, with its wide variety of climates, on Venus, there's nowhere to hide from this inferno.
Because Venus's atmosphere is so thick, the conditions on the surface of Venus don't vary very much at all between the equator, the poles, the day side, and the night side. Even when it's night on Venus, the rocks are glowing ever so slightly from their own heat. You would see this sort of glowing, dull, red-orange glow from the rocks because it's so hot.
So, what would happen if Earth were to soar to 900 degrees? As the thermometer rises toward the temperature of Venus, towns and cities around the world begin to smolder.
Ray Bradbury was right. Paper really does start blowing up at Fahrenheit 451.
Skyscrapers around the world turn into towering infernos.
The outer rooms of the building would be what burns hottest. That's because it's most exposed to that 900-degree furnace from the outside. The outside of the building would probably pull away, begin to drop off. Steel begins to soften and lose strength at 600 degrees Fahrenheit.
As the world goes up in flames, everything from homes to skyscrapers burns and collapses. Despite the heat on Venus, it's actually a dim, darkened world, shielded by clouds that blot out the sun. But those clouds hold a secret so deadly that even if you could survive the incredible heat and pressure of Venus, you'd never survive this. Despite its hellish 900-degree temperatures and crushing pressures, the surface of Venus is surprisingly calm and clear. But once you rise up into the clouds, that uniform heat and pressure are replaced by wild extremes of heat and cold. And Venus's weather rivals the most violent storms on Earth.
The clouds at the top of Venus's atmosphere are undergoing what's called superrotation. They're zipping around the planet in just 4 or 5 Earth days, moving at 200 miles an hour, kind of like strong hurricane winds here on Earth.
What's driving the circulation on Venus is this cold-hot contrast. As the sun is beating on the sunlit side, and the other side is not having any sunlight.
And so that imbalance is ultimately driving these strong winds around the planet.
As these winds reach the poles, they create one of the strangest weather conditions in the solar system. A cyclone with 2 eyes. And the super-rotating clouds of Venus have another nasty trait that would make it pointless to carry an umbrella.
The clouds on Venus are made of sulfuric acid. They are not very lovely clouds from our perspective. You wouldn't want to go flying in an airplane with the windows open through the clouds of Venus.
Especially because when these clouds rain, they rain almost pure sulfuric acid.
On Earth, we have coal plants that release materials that dissolve in rainwater, and it rains slightly acidic water. However, on Venus, we have an acid rain beyond comprehension.
It's so hot on Venus that the acid rain evaporates before it hits the ground. But what would happen if sulfuric acid ever rained down on the surface of the Earth? A simple experiment, mixing sulfuric acid with sugar, shows what it would do to the human body.
I have some sulfuric acid here in this beaker, and I have an organic compound that has lots of carbon and oxygen and hydrogen, actually just sugar from an ordinary kitchen. When I add the sulfuric acid, what's going to happen, it's actually going to pull the water out, dehydrate it, and produce a violent chemical reaction. So first I should put on some safety equipment, make sure I don't get any of the fumes. So adding the sulfuric acid to the sugar, which we're doing here, would be the analog of what would happen on Venus if some of that sulfuric acid in the atmosphere got in contact with some organic life. Now, having stirred it, I'm going to get out of the way.
The sulfuric acid turns the sugar into a pillar of almost pure carbon. So, if it ever rained sulfuric acid on the surface of the Earth, most life would be reduced to carbon pillars just like that. But what about our cities and monuments? Paris, France. If a corrosive downpour of sulfuric acid descended on the iron structure of the Eiffel Tower.
As sulfuric acid hits iron, it turns the iron into iron sulfate. Iron sulfate is crumbly, grainy, it can crystallize, it's rather brittle, doesn't contribute to any strength at all. You will get a kind of a little bit of a green cloud around the Eiffel Tower because you have so much acid coming so fast. And then you begin to see the first little signs of failure in the arches that hold the entire structure up. And you begin to see a slight deformation, and some of the rivets begin to fail. And as they fail, the structure itself begins to warp on its own weight and then fall.
Venus wasn't always a world of broiling heat, crushing pressure, and sulfuric acid. There was a period when the weather was calm and water was plentiful. But then, something began happening to Venus that holds a vital lesson for the survival of life on our own planet. Venus started out as a watery planet like Earth, until a climate catastrophe stripped it bone dry. That catastrophe is key to understanding Venus's weather. And to understand that, you have to imagine this. One part of the story may trace back to the giant impacts from space that struck both Earth and Venus not long after they were formed. As the young Earth was cooling, a Mars-sized planet struck a colossal blow. Earth emerged from this collision as a rapidly spinning planet with a massive liquid iron core, perfect for generating a magnetic field. And that magnetic field protects Earth's weather from dangerous charged particles from the sun. Without it, they would penetrate our atmosphere and strip most of it away. A planet-sized body also struck Venus, but the result was very different. The impact slowed the spin of Venus so much that it takes 224 Earth days to make a single rotation. Some believe this slow spin is the reason Venus doesn't have a magnetic field.
The lack of a magnetic field on Venus had an important part in making it a kind of the brutal place it is today.
After this violent start, both planets cooled into very similar places, at least at first.
About 4.5 billion years ago, when the Earth and Venus were formed, they were quite similar, very similar in mass and shape.
Venus would have looked a lot like Hawaii's Kilauea volcano does today. But unprotected by a magnetic field, its atmosphere was at the mercy of the sun's charged particles. They broke up the water vapor on Venus, separating the hydrogen from the oxygen, then blowing the hydrogen into space.
Water molecules themselves were destroyed, the hydrogen was lost, the oxygen formed with carbon to make carbon dioxide.
Since carbon dioxide is a potent greenhouse gas, more carbon dioxide meant even more heat. And finally, Venus crossed a critical threshold where it was too hot for water to exist on the surface. What would happen if Earth ever crossed that threshold? Chicago's Lake Michigan. As the temperature soars towards the boiling point, Lakeshore Drive is about to become high and dry.
Water boils extremely fast at high temperatures. And once you get up around 600 degrees Fahrenheit, there's not much to keep the water from just going thump, and it's gone. You would end up with Lake Michigan becoming a very large, very thick cloud.
Venus crossed that critical threshold perhaps over 3 billion years ago in a runaway greenhouse effect. The temperature just kept rising, all the way up to 900 degrees. After that, the weather on Venus broiled for billions of years. But 600 million years ago, Venus suffered another global catastrophe. If it ever happened on Earth, even the most tenacious life couldn't weather that ultimate storm. Venus is the hottest planet in the solar system. One cause of its hellish conditions can be found in a unique disaster that changed its weather forever. A series of volcanic eruptions so huge they resurfaced the entire planet.
We think that 600 million, maybe a billion years ago, there was a massive release of volcanic energy from the surface. Magma just being released from these cracks in Venus, resurfacing the entire planet.
How could this have happened? It all goes back to the lack of water. On Earth, continents float on our liquid mantle, creating rifts and volcanoes that release heat from the interior in an endless process called plate tectonics. But that requires water.
On the Earth, that whole process is lubricated by the liquid water that is both in the oceans and also is part of the rocks that form the Earth's crust. On Venus, you don't have the hydration of the crust that allows plate tectonics to occur. And so every few 100 million years or so, you may get a huge sort of pulse of melting lava, which completely resurfaces the entire planetary surface.
This catastrophe didn't just resurface the planet, it made the weather even more brutal.
When you resurface an entire planet with lava, you're emitting enormous amounts of noxious gas into the atmosphere. That resurfacing event would have given the planet the look and feel that it has today.
Some say Venus is a grim, worst-case study of what could happen to Earth if today's global warming somehow led to a runaway greenhouse effect. But even if we could solve global warming, the sun is destined to heat up over hundreds of millions of years. As it does, the fate of Venus is likely to descend upon Earth.
Eventually, the Earth will experience a runaway greenhouse. The sun gets brighter as hydrogen burns to helium, and eventually we will go the way of Venus. But that's a long time away. Our calculations suggest that it's 100 to 500 million years from now.
So the weather on Venus is really an advanced look at what's going to be happening on the Earth. For the very distant future of life on Earth, we're going to be facing all the challenges which Venus currently faces.
It's lucky we don't have to face those conditions today. If we did, our lakes and oceans would boil away. Our buildings would melt. Our monuments would crumble.